Running a FastMCP server in Claude Code shouldn't mean manually managing Python versions, project paths, and dependencies every time you want to test something. You'll see exactly how to launch servers with precise environment control, whether you need Python 3.11 for compatibility, a specific project directory for dependencies, or just a clean way to bundle everything into a single command. The pattern handles the heavy lifting so you can focus on building tools, not debugging setup. Hash with specific Python version. Claude MCP add ML server. UV run Python 3.11 with FastMCP run server. Hi. Hash within a project directory. Claude MCP add project server. UV run project path to project with FastMCP run server. Hi. This demonstrates the command composition pattern for integrating local development tools with AI assistance. The approach chains specialized CLI commands like UV run and FastMCP run through a parent orchestrator, Claude MCP add, creating a pipeline that handles environment setup, dependency resolution, and process execution as a single atomic operation. What makes this distinctive is how it encapsulates complex toolchain interactions behind a simple, declarative interface. The pattern works by layering abstraction over low-level operations, where each command in the chain handles one concern. UV manages Python environments and dependencies. FastMCP initializes the server runtime, and Claude MCP add registers the service with the AI client. This separation of concerns lets developers specify what they need: Python version, project context, dependencies, rather than how to achieve it, while the framework coordinates the underlying execution flow. This approach solves the problem of environment fragmentation when bridging local development tools with external systems. Without it, you'd manually configure virtual environments, install dependencies, expose endpoints, and register services, each with its own failure modes. The composition pattern is particularly valuable for AI tooling, where reproducibility and isolation matter, but you don't want to sacrifice the flexibility of local development workflows. The trade-off is a slight learning curve for the command structure, but it eliminates hours of manual setup and debugging. Let's break it down line by line. Hash with specific Python version. Claude MCP add ML server. UV run Python 3.11 with FastMCP run server. Hi. This registers a new MCP server named ML server with explicit Python 3.11 runtime. The with FastMCP flag ensures FastMCP's optimized execution environment, while UV run handles dependency isolation and version pinning for reproducible deployments. Hash within a project directory. Claude MCP add project server. UV run project path to project with FastMCP run server. Hi. This runs the FastMCP server scoped to a specific project directory. The project flag isolates dependencies and configuration to that path, preventing conflicts with system-wide or other project setups. Use this when you need environment consistency across deployments. FastMCP environment control. The Python, project, and with flags give you surgical precision over execution environments, letting you specify Python versions, dependency isolation, and project contexts without modifying server code. Environment variables must be explicitly passed through CLI flags or env files, as MCP clients run in completely isolated environments with no shell access. This pattern enables reproducible server execution across any machine while maintaining zero configuration simplicity for local development.
The server that knows nothing of its environment controls every environment